Hi guys, welcome back to Calcify videos. We're back with another video. In this video we're going to be talking about how to solve question 5 from AP Calculus 2019 free response portion. So in this problem we're given a graph, as you can see, and also we're given the region R enclosed by x equals 0 line and x equals 2 line, and also between these two curves. So what are those two curves? Basically, we have g of x, which is the bottom function, bottom curve. We have also h of x, which is the top curve. Okay. So basically, our ultimate goal is to figure out the area in between these two curves. So part A, let's get started. So basically, area R, I'm going to find the area with respect to x, which means I'm going to be using the x coordinates for the top, upper and the lower limit. So from 0 to 2, top curve minus bottom curve dx. So we know that the top curve is h of x, which is 6 minus 2 times x minus 1 all squared, minus the bottom curve is g of x, which is negative 2 plus 3 times cosine pi over 2x and dx. So let's simplify this expression a little bit. So we get from 0 to 2. So from here, negative times, it's going to become positive. 6 plus 2 is going to be equal to 8. 8 minus 2 times x minus 1 all squared, minus 3 times cosine pi over 2x and dx. Alright, so we're going to find the definite integral of this expression. Alright, so let me move on to this part. So before that, I need to erase that part. Alright, so that's going to be equal to, region R is going to be equal to, if I take the integral 8x minus 2/3 times x minus 1 to the power of 3, and pull minus 6 over pi times sine pi over 2x. So I need to evaluate this expression at x equals 2 and also x equals 0 by applying the first fundamental theorem of calculus. I'm sorry, this part has to be positive. So first, let's substitute 2. So we get 8 times 2 minus 2/3 times 2 minus 1 to the power of 3 plus 6 over pi times, it's going to be equal to just sine pi. So we're going to calculate this part first. So this is going to be equal to 16 minus 2/3, and sine pi is 0. 0 times 6 over pi is going to be equal to just 0. So we got this part, 16 minus 2/3. So it's going to be equal to 46 over 3. Okay. Let's plug in 0 into this expression. And that's going to be equal to 8 times 0 minus 2/3 times 0 minus 1 to the power of 3 plus 6 over pi times pi over 2 times 0 is going to be equal to just sine 0. So we know that sine 0 is 0, so this product is going to go 0. So we got this 8 times 0 is 0, negative 2 over 3 times negative 1 over to the power of 3, it's going to be equal to positive 2/3. So positive 2/3. So according to the fundamental theorem of calculus, we need to figure out the difference between these two. Okay, so it's going to be equal to 46 over 3 minus 2/3, which is equal to 44 over 3. So that's my answer. That's the area R. Okay. So let's move on to part B. And part B says the region R is the base of a solid. So for the solid at each x, the cross-section perpendicular to the x-axis has area A of x is equal to 1 over x plus 3. So find the volume. So solution. Okay. And part B. So in part B, if each cross-section perpendicular to the x-axis is A of x is equal to 1 over x plus 3, after we cut the entire solid into thin slices, between x equals 0 and x equals 2, so we can get the volume by adding up those areas, because volume is going to be equal to v equals from 0 to 2a of x dx, which is equal to from 0 to 2 1 over x plus 3 dx, and this is going to be equal to ln x plus 3 from 0 to 2. So how I got this expression? By just applying the u substitution. If you set x plus 3 equal to u and differentiate both sides and then plug them back into this original integral, we're going to get this x ln x plus 3 from 0 to 2. So if I plug in 2, we're going to get f ln 5 minus, if I plug in 0, we're going to get ln 3. So that's the volume. Okay, that's part B. So part C, let's move on to part C. It says, write but do not evaluate an integral expression that gives the volume of the solid generated when r is rotated about the horizontal line y equals 6. Okay, so let me clean up the board first, and then let's focus on part C. Alright, part C. Alright guys, in order to tackle this problem, we need to figure out the inner radius and outer radius. So if you visualize the situation that the inner radius is going to be equal to, 6 minus h of x. So outer radius is going to be equal to 6 minus g of x. Okay, so now it's time to set up the definite integral for the volume. So the volume is going to be equal to pi times from 0 to 2, 6 minus g of x, which is the outer radius, to the power of 2, if we apply the washer method, minus 6 minus h of x, which is the inner radius, to the power of 2 dx. So that's my integral that I need to set up for the volume. Okay, after we figure out the inner radius and the outer radius. Alright guys, in this problem we talked about how to find the area in between curves, how to find the volume for the cross sections. Thanks so much for watching this video. Don't forget to subscribe, like, share, and comment. Bye bye.